Hi everyone, and welcome back to Matthew's Search. Today we're going to be talking about probability and two-way tables. To start off, let's compare theoretical probability with experimental probability. Theoretical probability is based on what should happen, and a way to calculate this is by taking the favorable outcome and dividing it by the total possible outcome. So for example, we have here, a die has a 1 out of 6 chance to land a 4. Theoretically, in contrast, experimental probability is based on data from actual trials, so when we're actually experimenting. So a way to calculate this is by taking the event occurs and dividing it by the total number of trials. The example here says, in 10 die rolls, you may land a 4 3 times. So the experimental probability according to these trials, according to the results from these trials, the probability of landing 4 is 3 in 10, or 30%. So for our first problem, we're given that there are 32 students in an algebra class. And out of those 32 students, some own classes, or own contacts, or own neither. So where this falls is the total number of students in the class is 32. It goes here in the bottom right corner. Then we're told that some own glasses, some own contacts, and some have neither. Now, the two categories I want to highlight the most right now is glasses versus contacts. Those are going to be the ones that we're actually measuring here. So these two represent those who own glasses or don't own glasses, and this here represents and those who don't own contacts. Now, if we look at it this way, we're reading down the column and also across the row. So down the column, we're shown how many of these 32 students own glasses. So regardless of whether it falls with the C or the no C, those who fall under or down this column own glasses. The same goes for this, those who don't own glasses. The same rules apply for those who own contacts and those who don't own contacts. Now, we see here, it says 11 students own glasses. So again, among the 32 students, 11 own glasses. So that's going to go here in the total of those who own glasses. And it also tells us that 8 own contacts. So it's going to go here. This is in our contacts row. Now we have this information. We know that there are 11 who own glasses and 8 who own contacts. And we know that there are 32 students total. So what we do here is we're going to subtract 32 minus 11 to give us this value here. Why? Because we also add across. We add across rows. So these two will add up to 32, and these two will also add up to 32. Therefore, we can subtract to find the missing values. So that's why we do 32 minus 11 gives us 21. And we also do it this way on the column. 32 minus 8 gives us 24. Now that we have that information, we know 21 goes here and 24 goes here. However, we're given one more piece of information. It says the probability of owning either glasses or contact is 13 out of 32. So, the probability of owning either glasses or contacts. So, that means you might own glasses or you might own contacts. So, we have to include both possibilities. So, the probability of owning glasses is represented down this column, but the probability of owning contacts is represented across this column. Now, the reason why it isn't represented in this box right here is because this box is at the intersection of no glasses and no contacts, so it's the opposite of having either glasses or contacts. So it tells us it's 13 out of 32. So that means that every within this box is going to add up to 13. So if we know that, we need to solve for what's in here before we can solve what's in here. The reason being is because, as I said, the opposite of having either glasses or contacts is having neither glasses and neither contacts. Now, a way to calculate this is by taking the total, which is 32, and subtracting it by 13. And we're going to get 19. That is the probability of not owning glasses and the probability of not owning contacts. So once we get that, now we can solve for what's in here. Because now we have 24 and 19. So that means that whatever goes in this box has to add to 19 to give us 24. So we can just do 24 minus 19, give us 5. We get 5 here. Now we can add upwards, or we can subtract upwards. We can do 11 minus 5, gives us 6. And then we can subtract horizontally. 8 minus 6 will give us 2. Therefore, all we really did was find the missing values by either subtracting or adding the values that we already knew. So just to explain furthermore, we can see here the relationship between the rows and the columns. So we see that the rows add across and the columns add down. Now there is something else I also want to introduce, which are these symbols right here, the and or symbols. Now, a way to memorize the and or symbol, or to differentiate them, is the and symbol looks like the letter N in the word and. So whenever you see a symbol like this, all it's saying is what's the probability of A and B. But now if you have a symbol like this, it's saying the opposite. It's saying what's the probability of A or B. Now in this case, using the letters that we have here, the variable, if we were to solve for the probability of A and B, that means it would have to have A and it would also have to have B. So it would only fall under here, which is A over the total. But now if we were talking about the probability of A or B, that means anything that falls under A and anything that falls across B. So it's everything but E. So one way we can solve this is by taking the total and subtracting it with E, or we can just add the values that are inside, A plus B plus D. Therefore, the key takeaways is that in a two-way table, rows add across or horizontally, and columns add vertically, as we saw here. It added horizontally, it added vertically. Either way, I also want you to take away that this symbol means or, and this symbol means and. Last but not least, the opposite of the probability of having either or of something is having neither. And last but not least, everything in these first 4 squares will always add up to the total, as well as whatever these two will add up to the total, and whatever these two will add up to the total.